Alright guys, so now we look at thermal energy. Alright, so what is thermal energy? Well, really it's just freezing, melting, just things changing from one thing to another, right? So we're going to talk about how heat gets transferred. Alright, so first off, let's look at boiling and condensation points, right? Alright, so freezing point, melting point of a substance, they occur at the same temperature. So really, don't let that confuse you. What it is that the freezing point, right, is where it's going from a liquid to a solid. Alright, so what that means is it's losing kinetic energy, so slowing down, they get locked into place. Right? The melting point, just opposite. They're going from a solid to a liquid, but now what's happening is it's gaining kinetic energy or heat, and now the molecules start to break apart and move. Right? So they're the same thing, just in reverse. Alright, boiling point, alright, also known as condensation point, right? They're the same thing. So what's happening? Well, at the boiling point, the liquid's going to a gas, right? So the substance is gaining enough energy that they break apart from being a liquid into a gas. And then with the condensation, right, same thing, the gas is turning into a liquid. Well, it loses kinetic energy, so it slows down enough that instead of being a gas, they get attracted to each other and become water. Alright, so that's freezing point, melting point, boiling point, condensation point, right? They're all happening, they're both happening at the same time. Alright, so now let's look at the heating curve, alright? So as I'm talking about boiling point, right, and melting point, alright? So as the temperature increases, right, I've got a solid piece of ice. So when it reaches that temperature of 0 degrees, right, it starts to go through a phase change. Right? So right here, that green line there, that's where I'm getting melting occurring, right? And so the melting point happens, but the temperature is going to stay the same until every molecule has melted and becomes liquid, right? And well, when that happens, then the temperature can continue to rise. Now it gets to that boiling point, right, which is 100 degrees Celsius there. And so every molecule is going to continue to boil. It's going to stay at that same temperature until they all reach that part where they can turn into a gas, right? So the plateaus, the green areas right here and here, those are our phase changes, right? That's where it's going from solid to a liquid or liquid to a gas. All right, so the temperature is going to remain the same until every molecule changes. All right, so cooling curve. So now let's go in the opposite way. So you notice that the kinetic energy is going down on this. So I'm going to go from condensation to freezing, right? So here I've got the gas. It starts to cool off. Well, it's going to hit that condensation point at 100 degrees, right? And it's going to start to condense. Well, that temperature is going to stay the same until every molecule turns into a liquid, right? Once it hits liquid, okay, then as the temperature drops, it's going to reach that point where it starts to freeze, the freezing point, and that's at 0 degrees Celsius. And then everything's going to stay at that temperature until all the molecules have frozen, and then it becomes a solid. All right, so same as before. All right, so on to thermal energy. All right. So temperature and heat. All right. What are the differences? What is it? Well, temperature is related to the average kinetic energy of particles in a substance. So it's really not how much heat there is. It's really how fast are those molecules moving. All right. So here's an example. Right. You got a horseshoe that's really hot. All right. The particles are moving very, very quickly, so quickly that they give off light. Right. They glow red. Whereas you got a horseshoe here that's cooled off. Right. It's still moving, but not moving fast enough to break apart or to give off light energy. Alright, so that's the temperature there. Alright, so what are our units for temperature? Alright, so we use Kelvin, but usually scientifically we'll use Celsius. But the reason we like to use Kelvin is there's no negative numbers, right? 0 is absolute 0. That's as cold as it can get. But Celsius is just as easy for some things. So the formula here, if I want to go from Kelvin to Celsius, I just add 273. Right? So here I got 10 Celsius, it jumps up to 283. Or if I want to go from Celsius to Kelvin, I just subtract 273. So 10 degrees Kelvin would be negative 263 Celsius. So that's pretty cold. Thermal energy, right? That's the total of all the kinetic and potential energy of all the particles in the substance, right? So how much energy does it have kinetically, potentially, right? How can they be turned into that energy that we're looking at? Alright, so there you go. You got as kinetic energy increases, potential energy increases, right? So you get the separation of those molecules. Alright, so what is the relationship with thermal energy? Well, as temperature increases, so does thermal energy, right? Because those particles are starting to move faster, so the energy is increased. Right? So even if the temperature doesn't change, the thermal energy in a more massive substance is higher because it's a total measure of energy, right? So think of like your pool, right? It may take a while for your pool to heat up, but that doesn't mean it's not getting higher thermal energy, right? So you'll also notice that it takes a lot longer for it to cool down. All right, so heat, right? What is heat? So we figured out what temperature is, right? That's kinetic energy. Well, heat is the flow of thermal energy from one object to another. So really, there's no such thing as cold, right? It's just whether or not there's heat going in or going out of that object, right? So heat always wants to flow from warmer to cooler, right? It always wants to go from hot to cold, right? And so here, right, I'm holding the coffee mug. Well, that feels hot, but the reason it feels hot is because the heat is transferring from the mug into my hand. Whereas an ice cube, right, feels cold because, well, I'm holding it, and so the heat from my hand is going into the ice cube, right? It's pulling the heat out. So there's really no such thing as cold. It's just whether or not there's a difference in temperature, right? So it feels cold, but really it's just the heat moving from my hand to it. All right, so different types of heat transfer. All right, well, the three main kinds, and if you've been camping lately, you might have realized, oh, I've got a sunburn, even though I was just at the camp, right? Well, you get radiation coming off of the fire, right? So you can get you a nice sunburn actually just by sitting by a fire, right? This person's heating up some water in a pan, right? So that conduction, right? That's coming from objects actually touching each other, so that his hand's starting to feel the heat from the fire there. And then you got convection, and that's the flow of this liquid from hot to cold, right? The warm water rises, the cooler water sinks, and it creates that convection current. All right, so different types, right? So here we go, conduction, right? Conduction is that transfer of heat by direct contact. Occurs best in solids. It can happen in liquids, but it's always best in solids just because they're touching each other. All right. Convection, that's the transfer of heat through fluids by currents created due to density differences in parts of the fluid. So usually this happens in liquids and gases. And so you think of your central heat and air at your house, right? That's a convection. So the cool air flows in, right? Causes the warm air to be pulled into the air conditioner, and cool air is pushed back out, right? So, or you're heating, you push hot air in, the cool air is being pulled out. It's convection. All right, so here's some examples, right? You got boiling water, right? There's a radiator in the house, right? The hot air rises, heats the room, cool air comes back in and comes back to the radiator, gets heated up again. Or here you've got a refrigerator, right? So what it does is it pulls the warm air in from up top, and then it circulates it and pushes the cold air out, and it just cools it and causes that convection inside the air conditioner or the refrigerator. All right. So radiation, last one. Radiation is a transfer of heat through space as waves of electromagnetic radiation. Um, it's the only type that can really travel through space, right? So we usually get this from the sun. Okay, so this is what creates our seasons, right? Depending on which way our axis is tilted, right? That's going to make summer, winter, fall, spring, all those different things that are going on. So we get that radiation. Luckily for us, we've got our atmosphere that protects us from some of that radiation, so we only get some of it, not all of it. Okay, so we'll pick up on the rest of this on the next unit of notes.